Right now, in the equatorial Pacific, the ocean is warming, not by a little. An official El Niño watch is in effect, the kind of language that gets used when the signal is strong enough that staying quiet is no longer an option. The sea surface temperatures climbing across the central and eastern Pacific right now are pointing toward a strong event, possibly very strong. The odds of it lasting through this winter sit at 96%. 96%. The forecasters are already using the word Godzilla. The last time forecasters used it, the winter of 2015-16, when the equatorial Pacific ran temperatures that matched the strongest El Niños ever recorded, California was promised a drought-ending deluge. Every model pointed at the state. Every forecast said the same thing. This was going to be the one. Southern California got 81% of its normal rainfall that season. But before you decide what that means for this winter, before you decide whether to trust the forecast or ignore it, there's something about 2015-16 that almost nobody covered, something that changes what that number actually means. In February 2017, scientists assessed what happened to 29 beaches along 1,040 miles of west coast during that same winter. Beach erosion was 76% above normal. Every beach in the survey pushed past its historical extreme. Wave energy equaled or exceeded every measured maximum on record. The conclusion was unambiguous. Wave conditions and coastal response were unprecedented for many locations during the winter of 2015-16. The ocean didn't fail to show up. The ocean showed up harder than it ever had in the measurement record and destroyed California's coastline while the state stayed dry. Those are two things happening simultaneously that the disappointing El Niño story never reconciled. Which means the question isn't whether the next Godzilla will be powerful. It will be. The question is something nobody has properly answered since 2016. If the ocean arrived with that much force, where exactly did the rain go? To understand what happened in 2015, you need to look at what happened 10 years before it. The winter of 1997-98 was also a Godzilla. Sea surface temperatures in the equatorial Pacific climbed to nearly identical levels, within a fraction of a degree of 2015-16 by every standard measurement. The two events were ranked as the strongest El Niños in the modern record. Same ocean, same warming, same forecasts pointing at California. Southern California received 289% of its normal rainfall that winter. Not 110%, not 189%. The state flooded. 17 people died in storm-related events. There were $550 million in damages across California's coastal zone alone. The Sierra Nevada buried itself in snow. The reservoirs filled. That's what a Godzilla El Niño looks like when it arrives. 18 years later, an El Niño of identical strength gave Southern California 81% of normal rainfall, not a different category of event, not a weaker signal. The same category, the same raw ocean temperatures, ranked alongside 1982-83 and 1997-98 as one of the three strongest El Niños ever recorded, and the outcome was the opposite. The explanation took 2 years to find. In 1997-98, the maximum sea surface temperature anomaly during late winter sat near 120 degrees west longitude, close to the coast of South America, deep in the eastern Pacific. That positioning generated intense atmospheric convection far east in the ocean, which triggered a chain of atmospheric responses that pushed low-pressure systems directly across North America and into California. The storms had a pathway. They followed it. In 2015-16, as late winter arrived, the warm water maximum retreated. It shifted westward, sitting closer to the international date line than to South America. 5 degrees of longitude. That's roughly the distance from Los Angeles to Las Vegas projected onto the surface of the ocean. and that shift moved the entire atmospheric wave, the teleconnection that California depends on to steer Pacific storms inland, away from North America entirely. The storms didn't disappear. They went to Portland. 6 of the 8 best climate forecast models on Earth predicted a wet California winter that year. All 6 were wrong. The 2 models that correctly placed the warm water anomaly also correctly predicted the dryness. The other 6 forecast the wrong ocean and got the wrong answer. So now the question sharpens. The warm water drifted west in 2015-16 when it hadn't in the 2 previous strong events. 6 of 8 models didn't see it coming. Something pushed that water west, and whatever it wasn't El Niño itself. Here's what the models were looking at in the winter of 2015-16. The Pacific Ocean. Just the Pacific. That's where El Niño lives. That's where the warm water was. That's where every forecast model on Earth had its attention. Reasonable, logical, also incomplete. Because while everyone was watching the Pacific, something was happening in the Indian Ocean that the models weren't built to fully account for. In 2015-16, sea surface temperatures in the Indian Ocean broke their own all-time record by nearly half a degree Celsius. The Indian Ocean, a completely separate basin, thousands of miles from California, with no obvious connection to whether it rains in Los Angeles, was running the hottest temperatures ever measured in that body of water. And that warming created atmospheric conditions that intercepted the response El Niño was supposed to trigger over California. The warming was unrelated to El Niño, a different ocean. Making the decision, El Niño did everything it was supposed to do. The Pacific warmed. The atmospheric machinery began to respond. The chain of events that in 1997-98 had pushed 289% of normal rainfall into Southern California started moving. And then the Indian Ocean, running temperatures that had never been recorded before in that basin, created an atmospheric pattern that pushed California's storms north. Portland got the rain, California got the waves. The monster showed up. Another ocean sent it the wrong direction. The Indian Ocean breaking its temperature record in 2015-16 could be explained as a one-off, an anomaly. Something that aligned badly with an already unusual El Niño and produced an outcome unlikely to repeat. That would be the comfortable version of this story. The comfortable version isn't accurate. The Indian Ocean is the fastest warming major ocean basin on Earth, not the Pacific, the ocean everyone watches for El Niño signals, not the Atlantic, the Indian Ocean. It has been warming at a rate that outpaces every other major basin, and the temperatures it was running in 2015-16 and 16, the record-breaking readings connected to California's missing rain, weren't a fluke. They were a preview. What that means in practical terms, the interference pattern that redirected Godzilla's rain north in 2015-16 wasn't a random atmospheric event that happened to coincide with a strong El Niño. It was a signal from a warming ocean that is becoming more capable of that interference every year. The same mechanism, getting stronger. And the forecast models, the ones that already missed it once, are still catching up to what the Indian Ocean is doing to their predictions. Every spring, forecasters hit a window where their skill drops sharply, a period when the models lose their grip on what the Pacific is about to do. That window is getting wider, not because the models are getting worse, because the system they're tracking is getting harder to read. And it's getting harder to read precisely as the ocean interfering with it gets more powerful. The forecasters aren't getting worse. The problem is getting harder. And right now, this month, this season, there's an 82% probability on El Niño forming by summer. A 2 in 3 chance it becomes strong or very strong. The uncertainty in its ultimate strength is substantial. The same uncertainty that existed in the summer of 2015. The Indian Ocean is warmer now than it was then. A strong El Niño is forming in the Pacific. The forecasters are pointing at the state. And there's something worth sitting with in that similarity. Not because history always repeats. It doesn't. The 1997-98 El Niño delivered everything it promised, and then some. The 1982-83 event gave Northern California 212% of normal rainfall. Strong El Niños have rescued California before, and they'll do it again. The Indian Ocean doesn't interfere every time. But here's what's different now. The Indian Ocean this summer is running temperatures higher than it was running in the summer of 2015. The same ocean that quietly redirected Godzilla's rain to Portland 10 years ago. The fastest warming major ocean basin on Earth has kept warming in the decade since. Whether it interferes with this El Niño the way it interfered with the last one, nobody can say with certainty yet. The models have been updated. Some of them are better. The physical system they're trying to track has also changed. California's water infrastructure, the reservoirs, the aqueducts, the entire capture and distribution system the state runs on was built around one assumption: that Sierra Nevada precipitation falls as snow, accumulates through winter, and melts slowly into spring and summer, releasing stored water exactly when the state needs it. El Niño gives California warm storms. Warm storms give rain, not snow. Rain runs off immediately. The preference has always been to let it sit up in the snowpack and gradually melt down in the spring. The reservoirs have to stay partially empty in winter for flood control. When an El Niño rain bomb hits, water managers face a choice that has no good answer: hold the water and risk flooding downstream, or release it to the ocean and lose the supply. The infrastructure was designed for a filing schedule the climate no longer follows. So the honest version of where California stands is this: if the Indian Ocean stays quiet this winter and the El Niño delivers, the rain may come in a form the state can only partially catch. If the Indian Ocean runs hot and redirects the storms north again, California gets the waves without the water, same as last time. Two different failure modes. Both of them live. What happened in 2015-16 wasn't a forecast error that better models will eventually fix. It was a signal from a system that is changing faster than the infrastructure built around it. The beaches that eroded beyond every historical extreme that winter, while the state stayed dry, while the reservoirs stayed low, while everyone waited for rain that went to Portland instead. Those beaches didn't fully recover. Some of them still haven't. The Godzilla forming right now will be powerful. That part is almost certain. Whether California feels it, that question doesn't have a clean answer yet. It didn't in 2015. The Indian Ocean is warmer now than it was then. The models are working harder to track a system that's harder to track, and the infrastructure waiting to catch whatever falls was built for a different century's rainfall. Watch the Indian Ocean, not just the Pacific.